mountainside, or even up one of those small ravines in the hillside, which have generally a little stream trickling through them? If so, you must have noticed the number of pebbles, large and small, lying in patches here and there in the stream, and many pieces of broken rock, which are often scattered along the sides of the ravine, and how, as you climb, the path grows steeper, and the rocks become rugged and stick out in strange shapes. The history of this ravine will tell us a great deal about the carving of water. Once it was nothing more than a little furrow in the hillside, down which the rain found its way in a thin, thread-like stream. But by and by, as the stream carried down some of the earth, and the furrow grew deeper and wider, the sides began to crumble when the sun dried up the rain which had soaked in. Then, in winter, when the sides of the hill were moist with the autumn rains, frosts came and turned the water to ice, and so made the cracks still larger, and the swollen stream rushing down caught the loose pieces of rock and washed them down into its bed. Here they were rolled over and over, and grated against each other, and were ground away until they became rounded pebbles, such as lie in the foreground of the picture, Fig. 25, while the grit which was rubbed off them was carried farther down the stream. And so in time this became a little valley, and as the stream cut it deeper and deeper, there was room to clamber along the sides of it, and ferns and mosses began to cover the naked stone, and small trees rooted themselves along the banks, and this beautiful little nook sprang up on the hillside entirely by the sculpturing of water. Shall you not feel a fresh interest in all the little valleys, ravines, and gorges you meet with in the country, if you can picture them being formed in this way year by year? There are many curious differences in them which you can study for yourselves. Some will be smooth, broad valleys, and here the rocks have been soft and easily worn, and water trickling down the sides of the first valley has cut other channels so as to make smaller valleys running across it. In other places there will be narrow ravines, and here the rocks have been hard, so that they did not wear away gradually, but broke off and fell in blocks, leaving high cliffs on each side. In some places you will come to a beautiful waterfall, where the water has tumbled over a steep cliff and then eaten its way back, just like a saw cutting through a piece of wood. There are two things in particular to notice in a waterfall like this. First, how the water and spray dash against the bottom of the cliff down which it falls, and grind the small pebbles against the rock. In this way the bottom of the cliff is undermined, and so great pieces tumble down from time to time, and keep the fall upright instead of its being sloped away at the top and becoming a mere stream. Secondly, you may often see curious cup-shaped holes, called potholes, in the rocks on the sides of a waterfall, and these also are concerned in its formation. In these holes you will generally find 2 or 3 small pebbles, and you have here a beautiful example of how water uses stones to grind away the face of the earth. These holes are made entirely by the falling water eddying round and round in a small hollow of the rock, and grinding the pebbles which it has brought down against the bottom and sides of this hollow, just as you grind round a pestle in a mortar. By degrees the hole grows deeper and deeper, and though the first pebbles are probably ground down to powder, others fall in, and so in time there is a great hole perforated right through, helping to make the rock break and fall away. In this and other ways the water works its way back in a surprising manner. The Isle of Wight gives us some good instances of this. Alum Bay chine and the celebrated Blackgang chine have been entirely cut out by waterfalls. But the best known and most remarkable example is the Niagara Falls in America. Here the river Niagara first wanders through a flat country, and then reaches the Great Lake Erie in a hollow of the plain. After that it flows gently down for about 15 miles, and then the slope becomes greater, and it rushes onto the Falls of Niagara. These falls are not nearly so high as many people imagine, being only about 165 feet, or about half the height of St. Paul's Cathedral, but they are 2,700 feet, or nearly half a mile wide, and no less than 670,000 tons of water fall over them every minute, making magnificent clouds of spray. Sir Charles Lyell, when he was at Niagara, came to the conclusion that, taking one year with another, these falls eat back the cliff at the rate of about 1 foot a year, as you can easily imagine they would do when you think with what force the water must dash against the bottom of the falls. In this way a deep cleft has been cut right back from Queenstown for a distance of 7 miles to the place where the falls are now. This helps us a little to understand how very slowly and gradually water cuts its way, for if a foot a year is about the average of the waste of the rock, it will have taken more than 35,000 years for that channel of 7 miles to be made. But But even this chasm cut by the Falls of Niagara is nothing compared with the canyons of Colorado. Canyon is a Spanish word for a rocky gorge, and these gorges are indeed so grand that if we had not seen in other places what water can do, we should never have been able to believe that it could have cut out these gigantic chasms. For more than 300 miles, the River Colorado, coming down from the Rocky Mountains, has eaten its way through a country made of granite and hard beds of limestone and sandstone, and it has cut down straight through these rocks, leaving walls from half a mile to a mile high, standing straight up from it. The cliffs of the Great Canyon, as it is called, stretch up for more than a mile above the river which flows in the gorge below. Fancy yourselves for a moment in a boat on this river, as shown in Figure 27, and looking up at these gigantic walls of rock towering above you. Even halfway up them, a man, if he could get there, would be so small you could not see him without a telescope, while the opening at the top between the two walls would seem so narrow at such an immense distance that the sky above would have the appearance of nothing more than a narrow streak of blue. Yet these huge chasms have not been made by any violent breaking apart of the rocks or convulsion of an earthquake. No, they have been gradually, silently, and steadily cut through by the river, which now glides quietly in the wider chasms, or rushes rapidly through the narrow gorges at their feet. No description, says Lieutenant Ives, one of the first explorers of this river, can convey the idea of the varied and majestic grandeur of this peerless waterway. Wherever the river turns, the entire panorama changes. Stately facades, august cathedrals, amphitheaters, rotundas, castellated walls, and rows of time-stained ruins, surmounted by every form of tower, minaret, dome, and spire, have been molded from the cyclopean masses of rock that form the mighty defile. Who will say after this that water is not the grandest of all sculptors, as it cuts through the hundreds of miles of rock, forming such magnificent granite groups, not only unsurpassed but unequaled by any of the works of man? But we must not look upon water only as a cutting instrument, for it does more than merely carve out land in one place. It also carries it away and lays it down elsewhere, and in this it is more like a modeler in clay, who smooths off the material from one part of his figure to put it upon another. Running water is not only always carrying away mud, but at the same time laying it down here and there wherever it flows. Whenever a torrent brings down stones and gravel from the mountains, it will depend on the size and weight of the pieces how long they will be in falling through the water. If you take a handful of gravel and throw it into a glass full of water, you will notice that the stones in it will fall to the bottom at once. The grit and coarse sand will take longer in sinking, and lastly, the fine sand will be an hour or two in settling down, so that the water becomes clear. Now suppose that this gravel were sinking in the water of a river. The stones would be buoyed up as long as the river was very full and flowed very quickly, but they would drop through sooner than the coarse sand. The coarse sand in its turn would begin to sink as the river flowed more slowly, and would reach the bottom while the fine sand was still borne on. Lastly, the fine sand would sink through very, very slowly, and only settle in comparatively still water. From this it will happen that stones will generally lie near to the bottom of torrents at the foot of the banks from which they fall, while the gravel will be carried on by the stream after it leaves the mountains. This too, however, will be laid down when the river comes into a more level country and runs more slowly, or it may be left together with the finer mud in a lake, as in the Lake of Geneva, into which the Rhone flows laden with mud and comes out at the other end clear and pure. But if no lake lies in the way, the finer earth will still travel on, and the river will take up more and more as it flows, till at last it will leave this too on the plains across which it moves sluggishly along, or will deposit it at its mouth when it joins the sea. You all know the history of the Nile, how when the rains fall very heavily in March and April in the mountains of Abyssinia, the river comes rushing down and brings with it a load of mud, which it spreads out over the Nile Valley in Egypt. This annual layer of mud is so thin that it takes 1,000 years for it to become 2 or 3 feet deep. But besides that which falls in the valley, a great deal is taken to the mouth of the river, and there forms new land, making what is called the delta of the Nile. Alexandria, Rosetta, and Damietta are towns which are all built on land made of Nile mud, which was carried down ages and ages ago, and which has now become firm and hard like the rest of the country. You will easily remember other deltas mentioned in books, and all these are made of the mud carried down from the land to the sea. The delta of the Ganges and Brahmaputra in India is actually as large as the whole of England and Wales, 58,311 square miles. and the river